Start recording. I'm going to pass out these cards. Let's see, we got 1, 2, 3, 4, 5, 6, 7. Two groups of three, no, two groups of, one group of three, about however y'all want to group it up. I don't care. However y'all want to group it up. So let's say 3 groups of 2 maybe. How about that? So, just group up with somebody. I don't care who, but group up with somebody. And we're going to do, why not these 3 together, and then you 2, and then 2 guys together. How about that? Okay? You get 1 pack of cards and 1 die. So, 1 pack of cards and 1 die. And he's got all his stuff up here, and you were late, so come up here. All right, now the 120 class this morning, I had 4 groups, and 2 of the groups screwed it up. Okay? So please listen. You're going to need a piece of notebook paper. You're going to need a pencil. Okay? And you're going to need 1 person to write down, 1 person to shuffle. But you're going to have to shuffle each time. Wipe my glasses off of this thing. I thought this was supposed to be cleaner, and it's not. Let me try it one more time. Anyway, what you're going to do is you're going to pick 1 thing that you're going to try with the cards and 1 thing that you're going to try with the die. Let me give you an example. On the cards, you might want to pick a face card. You might want to pick a heart. You might want to pick an even card. You might want to pick a queen. But you have to come up with 1 thing. All right, let's say that I pick a queen. I say I want to see what the probability is of picking a queen. And I write that down, picking a queen, probability of a queen. And then I shuffle the deck, and I shuffle it 2 or 3 times, and then I ask somebody to pick 1 card, and then they pick a card, and I write it down. 2 of hearts. Okay, and then I shuffle, put the card back, shuffle. I want you to do it 10 times. Take 10 drawings. And you pick the second card, make sure that the jokers are out. I tried to take the jokers out, but there's 1 deck still has the jokers in. I don't know. Just check, make sure you have 52 cards. So you shuffle, then you ask somebody to pick another card. This is the King of Diamonds. You write that down, King of Diamonds. You write down all 10 draws. Do the same thing with the die. You pick a number, or you say, okay, what's the probability of an even roll? And then you roll it 10 times. Okay? Try not to roll it. Try to roll it within a certain area. Don't try to throw it on the ground or anything, because you want to keep it consistent. Try to keep it in the same area. Okay? So do that 10 times with each, and write down everything. Write down each number you roll. As you say, I want to roll 6. Okay? You write down probability of 6, and then you roll down each number: a 1, a 5, a 4, a 2. 10 times with die. 10 picks on the card. Make sure you shuffle the deck each time. Okay? Go ahead. We're going to talk about what happens after. And make sure the person that can shuffle. We got some people that can't shuffle cards on the I did not know that shuffling cards was a major thing, but until I started doing this, there are people that cannot shuffle cards. Huh?
I do not do it.
You don't know how to shuffle cards? Well, you're proud.
Can't have everything right.
Yeah, exactly. But you got a good personality, so that goes a long way. Just so long as you don't get tased when you're drunk, and don't ride lawnmower down the road. So write them down. We did this in the 120, and I had 2 groups totally screw it up. I mean, how do you screw this up?
After you get 1 card, you put it back?
Yeah, you always put it back, yeah. I'm going to give you a napkin. These my glasses. I don't know what's on.
I guess. You scared me for a second there. Hey, what did he tell you when you said you put it back?
Yeah, make sure the instruction card's not in there too. Yeah, that's a whole lot better. Oh, there's nothing worse in the world than having glasses that are 30. Well, I can think of a whole lot worse things, but y'all are not in the mood to talk to me today, so.
Well, I don't know the worst, I can't speak on something I don't know.
They need to fix that vending machine, it's pretty messed up.
Listen, I've been fussing. They don't have gummy worms.
But listen,
I had to buy these things. These things are nasty.
listen, they
Publix
got
has a
like,
great
it's
gummy
like,
selection.
where the Milky Ways are, it's like 3 Milky Ways, and then behind it, it's like a whole row of these cream rashes, and I don't really know that. I ain't buying 3 Milky Ways.
I understand.
And that's how it is with all of them, right?
I've been bitching.
It's not
I've been
full.
bitching about the gummy worms for the last 3 days.
It's not a full row of like whatever it is.
Publix has an unbelievable selection of gummies. I got some sour gummy bears the other night.
See, that's what a keto pizza looks like.
I need to take a look at the gums. I'm eating pizza and going for it.
Actually, I made it's called a fathead pizza. Where you take cream cheese and you make a crust out of cream cheese and cheese.
I could be about
Huh?
that. I could be about that.
And it's real good. Tell me when you're finished. All right, can you? Some people, you could have Skype, you could have a taxi service come to the school, you could have a bus come to the school, you could have videos on, and there would still be some way for students not to be able to get to. I ain't kidding you. Why do people even try? Oh, Lord.
You can't fix stupid, Hubert.
Well, you can't fix lazy either.
What is this stupid? What do you think I'm gonna talk about? You know, 45 minutes. I'm not
That's how we would have. Grant, we did have a couple of bad years after. We can use.
Yeah.
They told us to hire some people.
Like, it's a lot of things like that.
And they still have.
Y'all finished? Y'all finished? Y'all finished? Yeah. Okay, about finished. How about y'all?
No, we're not done.
Okay, finish up.
I'm just kidding.
Oh, you're done? All right. Okay, so let's get with your group. What did you pick? What card did you pick or suit? What did you pick for the cards? Aces. So the probability of an ace is equal to 4 out of what? 52. Okay, which is equal to 1 over 13. Somebody give me that decimal. What's 1 over 13?
0.077.
0.78 or 0.7. We'll say 0.8. Okay, that is called the Mayberry probability or the theoretical probability. Okay? Theoretical probability. Now, what did you write? Tell me the cards that you picked out of the 10. Give me the cards.
Like, list them all out.
What did you pick?
Oh, okay. My bad. 5 of spades.
I'm sorry, what?
5 of spades.
You picked the 5 of spades,
Queen of hearts.
Queen of hearts. Dang old song. What?
10 spades.
What?
10 spades.
10 of spades,
6 of spades.
6 of spades,
King of diamonds.
King of diamonds,
9 of spades.
9 of spades,
5 of clubs.
5 of clubs,
2 of clubs.
2 of clubs,
5 of diamonds.
5 of diamonds,
And 3 of clubs.
and 3 of clubs. So you asked for an ace and you didn't get jack. So the probability, that's the probability theoretical. Your physical probability of an ace is 0. Okay, this is a prime example of when the probability is 0. Does that mean it's impossible?
No.
No. You can pick an ace, but in this case, 10 times, because the probability, the theoretical probability is almost 10%. So if you was to do another 10 times, or another 100 times, or another 5,000 times, you might get to that 0.08. But in 10 times, you only got a probability of 0. All right? Let's talk about your die. What did you pick for the die?
4.
Probability of 4 is 0.17, which is 1 over 6. So let's, give me the numbers you did.
5.
5,
6.
6,
6.
6,
2.
2, 4,
6.
6,
1.
1,
6.
6,
1.
4,
3.
3. Okay, you got 0.2, which is 2 out of 10. Again, it's close, but why is it close? It's closer because you only got how many sides? Now, the part about a die that you don't understand is a die is more random than a deck of cards. The reason it's more random is because you could drop it the same place every single time and it ends up somebody totally different. It's called the chaotic theory. Okay? The reason it's chaotic is because it has how many corners? 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 corners. Okay? 8 corners. Each one, when it hits, each of those corners, it goes a different direction. So you could drop it in the same place every single time, and it end up totally somewhere else. Okay? That's why this is more random. But the reason the probability is so much lower is because of the what? because of the number of cards that you're picking from. If you only had 6 cards to pick from, probability would go very high. Okay? Even though this is very low, it's only 6 or 8 sides, 8 sides. It's only 8 sides. You got, different, is it 6 or 8 sides? 6 sides, yeah, 6 sides, 8 corners. Okay? Even though that's very small, the randomability, you've got a deck of cards. Those cards are just what? They're just sitting there. But you drop this die, different place, in the same place every single time, it goes all over the place because of the 8 corners. It's called chaotic theory. Have you ever heard of chaotic theory? Forget it. Just thought I would ask.
I think this one's loaded.
Huh?
I think this one's
You think it's loaded?
Yeah.
Well, look at here. What number showed up the most?
6.
So let's take that same die, and I'm going to talk to the gods, and I'm going to say, we're going to see the probability of rolling a 6. All right, roll it 10 times, and let's write down what we got. Roll it.
1,
1,
4,
4,
1,
1,
4,
4,
5,
5,
1,
1,
6,
6,
1,
1,
6,
6,
3.
3. Holly, what happened to our 6? As soon as we said it rolled 4 times over there, and as soon as we put our money on 6, it only read what? Twice. But which one rolled the most? 1. So let's go. Let's tell. We're going to do probability of 1. Same die, and we're going to put our money on 1. It'll do 4 or 5 times. Go ahead.
3, 5, 6, 4, 4, 2, 1, 3, 2, 4.
That die knows what we're doing, don't they? Doesn't it? No, it doesn't. You're talking about the random out. You got 8 of those corners, and those 8 corners are causing that die to do what? Go all over the place. Kind of like a ping pong ball in a room full of mouse traps. You ever seen that happen before?
Is that an expression? Is that an expression or like somebody's
I wonder what they teach y'all in K through 12 because
I feel that, but at the same time.
I mean, honestly, I really do, because it just blows my mind how. I ain't
Have you
gonna-
ever been to our game?
I go down there quite a bit. There's some wild women down there. All right, I'm gonna call it up. It's called ping pong ball, ping pong ball, and mouse traps. Can't believe I'm having to show y'all this. Physics. I took physics when I was in high school. It wasn't honors class in my day. That's when you had to take classes that didn't water them down. You either had to study your butt off or you failed.
Well, we don't care about that.
Yeah, exactly. Yeah, the only thing matters in high school is the first woman, the first black, the first this, the first that. That's all that matters in high school now.
We didn't have physics in Hart County.
Okay. Okay, all this. Okay, there's the ping pong ball. Actually, it takes away from it, showing it in slow motion. Yeah. Yeah, they're doing too much. Okay, now it's falling into another. Okay, there's. So anyway, that's what it is. Forget it. I picked the wrong. Let's see. Hopefully they won't screw this up. Oh my God, just do it. That's what it is. It's called chain reaction. But anyway, y'all learned something today. Forget it. Oh, we're still watching Steve. All right, so that's the randomization. That's what when you drop that die, it hits on those different corners, and that's called randomization. It's not a chain reaction, but it's called randomness. So you never know what's going to fall, and as you can see, you can try to predict, but even when you predict, what happens? It's like the die knows what you're predicting, and it turns around and throws other numbers up instead of the number that you predict. Okay? Same thing with the lottery. You could take the lottery and you could take the last 10 winning numbers and average them, or you could say which one shows up. But does that mean that it's going to show up again? No. This right here proves it. So, all right, what did y'all pick for a card?
Hearts.
Just hearts. Okay. So that would be the probability of a heart is equal to 13 over what? 52, which is equal to 0.25. All right. Now, a while ago, you chose a ace. And the probability of an ace, we're not going to use their probability because it was 0. But the probability of an ace would be 4 out of 52. So therefore, the probability of not an ace would be 48 over 52. So that would be 48 over 52, the odds against, over 4 over 52, multiplied by 52 over 4, which would be 48 to 4, which would be 12 to 1. So if you bet a $500 bet on pulling an ace, and you pulled an ace, you'd walk away with how much? $6,000, 5 times 12, isn't that 6? So that's 60. You walk away with $6,000. So if you made a $500 bet on picking an ace, like there was a game in Vegas, and you put down $500, and all you had to do was pick an ace. If you pulled an ace, you would walk away from that table with what? $6,000. Okay, let's see what happens with the hearts. We did go over odds against, right? I thought we did. Okay. So let's go with 0.25 or 13 or 52. What did you pull? Give me the numbers you pulled. I meant the cards. You just have to give me the suit. You don't have to give me the card.
6 of hearts.
Okay, you pulled a heart.
2 hearts.
2 hearts.
1 club.
1 club.
3 diamonds.
3 diamonds.
4 spades.
3 diamonds and 4 spades. So you got 2 out of 10, which is 0.2. Pretty close, but it's not 2.5. 25 cents is not 20 cents, and $25 is not $20. So it is a little bit off. But again, the randomness of the card is not as much as the randomness of the die. But let's go ahead and figure, what would we win off this one? Would we win more than $6,000 or less? Less, because the probability is what? Higher. Okay, let's check. So this is 13 over 52. That's the probability of success. Probability of failure, what's 13 away from 52? Is it 39? Yes, Hubert. Thank you, class. So that's 39 to 13, which is what? 3 to 1? So multiply 3 times 15, make a $500 bet. So what would you win? You'd win $1,500. Why would you win less money? Because the probability is what? Higher. The probability is higher, you win less money. Probability is lower, you win more money. What's the probability? What's 4 over 52? 1 over 13. What do we say that was? 0.08? Somebody check me. What's 4 over 52?
0.08.
Okay. Here's the probability of picking an ace. Here's the probability of picking a heart. So the probability is much lower with the ace, so you're going to make more money. But it's harder to what? It's harder to pull an ace. Same thing here. The opposite. It's easier to pull a heart, but you're not going to win as much what? Money. There's nothing free. Everything balances. Okay? So let's do last group. Let's do what y'all did. What did y'all do?
Do king.
I'm sorry, what?
King.
Okay, same thing. Face card or a king. Probability of a king is 0.08 or 4 out of 52. So the probability is going to be the same. What do we say it was? It's going to be, what was the 48 to 1? What was it on the ace? What was the odds against? 12 to 1, thank you. So it's 12 to 1, so it's going to be the same as the ace, so we don't have to. The $500 bet is going to be $6,000, so that's going to be the same. But let's see what the actual probability came out to be. Give me since it's a face card, give me the cards that you got. It doesn't matter about the suit.
We got the king of spades.
Okay, you got king, queen,
9,
9,
5,
5,
3,
3, 6,
10,
10,
9,
9,
2, and 5.
2, and 5. So here we got 0.1. And the probability is 0.08. It's close, but $100 is different from $80, or 80 cents is different from $1. So it's not exactly equal, but it's close. And again, you're going to see more closeness on the cards than you will on the die because the die jumps around so much. Okay? It has more randomness with the 8 corners versus a card just lays there and you just pick it. Okay? But at the same time, you've got less numbers on the die where you have 52 on the deck of cards. So that's a little experiment we do there. I do that with all my probability classes, especially the ones that can follow directions. Y'all did good. You followed directions very well, unlike the 120 class. 2 of them didn't write down anything. But anyway, the only other 2 things we're going to talk about today is the 2 laws of the additive property and the multiplicative property. The additive property is basically dealing with the word or. The multiplicative property is dealing with the word and. So if you ever see a question and it said, what is the probability of blank or blank, then you know that you're dealing with the additive property. If you, and we don't have much time to go over this, but we'll get started on it. With the or, the thing that you have to remember is always subtract the overlap. Okay? And with the multiplicative property, you have to remember 2 things. With replacement and without replacement. replacement is called independent. Without replacement is called dependent. Independent does not change future outcome. Dependent changes future outcome. Think of it like this. If you pull a marble from a bag and you put the marble in your pocket, that is dependent because now instead of 15 marbles, how many does it have? 14 marbles. Then you pick another one and you put it in your pocket. That's 13 marbles. Then you pick another one. Now you got 12 marbles. So the statistics or the probability changes with each marble you put in your pocket. So that's why without replacement, that's the one that you got to watch out for. Okay? With replacement, it really doesn't change anything because you just raise it. And we'll talk about these two when y'all come back. Right now, you should be working on, what chapter is this? 6? 7. You should be working on 7A right now, or 7B, whatever it has the probability in it. Okay? Y'all should be working on that homework. We're going to cover this. This is probably going to be like 7C and 7D. Probably going to be in the middle of the chapter. Okay? Y'all have a good day and a good weekend. Turn the recorder off.